So we are going to talk about Lustre metadata redundancy today. We've been thinking about it for a really long time. Unfortunately, it's not as well developed as the other things you've been looking at today, but we are getting there. It's actually getting some momentum behind it. So historically, Lustre have been mostly dependent on special hardware, all the dual ported hard drives, the special controllers that took lots of skill to develop and stuff. In addition to people, just doing some strange makeshift solutions, like I know for some time DRBD was being used and iSCSI, but those were mostly on the fringes because the actual. Yeah, I know. Is this any better? Now I have a terrible echo. The echo is really distracting. So anyway, a lot of a problem with those fringe approaches was that the big serious installations didn't want to use them because they were, not robust enough. But now that we actually have exascalers, I should say hyperscalers, right? Those people actually don't want any third-party hardware on their floor because it doesn't fit their paradigm and whatever. And so finally, it's actually making financial sense to work on all this stuff. So Lustre could finally become some sort of a totally software-defined solution where all the hardware features, all the stuff that like people used to say, your Lustre installation is only as stable as your hardware. So we are finally moving away from that. And basically, while the data path is well underway, the metadata is still not fully covered and it's kind of farther away, but this is why we are working on it and this is what's bringing it in. So when we say metadata, there are actually multiple bits that could be referred as metadata. And so the configuration service is one. This is how your clients know where to connect, where the servers are, all the stuff, all the node map configuration data, things like that. Then there are special services like Quota, the POSIX file logs for people that use them, other special resources like file system root, the global rename log, those kind of things. And then finally, the mirroring of the actual file and directory inodes, the file names, those kind of things, ACLs, that lots of people still refer to as metadata in traditional file systems, but yeah, we still have that much more stuff. So the fault-tolerant MGS, this slide is somewhat different from what you've seen in two other versions of the presentations because, this is still all in flux, at least to a degree. So we think we have found an easier way, and that easier way is today, like all the targets already have a copy of config information about themselves anyway. So if we just extend that to contain full copy of config information for all the targets, they could essentially become like proxies for the MGS and good enough to actually connect to for your clients. And even if the primary MGS is not available, the other targets are up as long as your clients could actually discover them somehow. They'll be able to connect and get the rest information there. And then eventually it'll kind of work with imperative recovery, which again, we long wanted to distribute that information. Right now, a single MGS, when it's bombarded by potentially tens of thousands of clients, could kind of get slower under the load. And so all of this stuff, by distributing to the cache, to the proxies, is going to take the load off of it. Just needs a little bit of more work so that this information could also be propagated. the actual selection of primary MGS is still an open question. So we could use Raft just like the other slides say, or you could just bring a new instance and resync from the caches, because the caches are all the same anyway. There's no super strong consistency guarantees needed, so that's kind of a less important problem in our view. So now to the Raft that was mentioned elsewhere. Some services do require strong consistency guarantees, and while we love to reinvent our bicycles, it does not always make sense to do that, and it turned out that there's this Raft consensus protocol that's widely used in the industry that's, it's pretty easy to understand, and it's relatively small. So we decided to port it and just use that. It basically has this leader election thingy where all the candidates, whoever first decides that they are the active one, they just talk to all the other candidates, and obviously they have to know about all the candidates anyway. And as long as more than half of known candidates agrees that there's no better candidate, the leader is kind of accepted, and the new reign or term in the terms of Raft begins, and the leader kind of commands this whole cluster. All the updates go through the leader. They're replicated to the client, to the, as they call it, followers, all the, polite, the whatever, inclusive speaker or whatever that's called. Nobody likes the old terms anymore. It brings back bad memories, I guess. So the leader constantly pings all the followers, like pretty frequently, and every follower, upon receiving such a ping, kind of increases a timer inside itself randomly. If any of the followers times out on this timer without receiving a ping, then it will decide that, okay, the leader must be dead, and it reinitiates the whole election again, talking to all the, whoever he could reach, and they would either confirm that, hey, look, yes, you are the new leader, or they say, nope, we still kind of have the old leader back, and it's just you that's the problem. So, pretty simple actually. Yeah, there's also a nice picture of all of the pings going to the selected leader and stuff. Yeah, that's right. So we have ported the Raft implementation to Linux kernel. You could see with the patches attached to those tickets. We would also use the Portal RPC network for actual communications, and it would integrate with Lustre LUG as the storage. All the initialization, all the handlers, all the callbacks, everything's kind of included. Every MDT service can be regarded as a Raft node, and we are even considering that maybe we should include other targets, but MGT as the first one. And then there would be corresponding services started, so FLDB and Quota at first, and we might eventually add MGS just for this, like a replacement of a primary node if that ever becomes necessary. The updates would be propagated through the leader, but that does not mean clients need to talk to the leader. We will include internal mechanisms so that any server should be able to forward the information to the leader that then gets distributed everywhere and committed. So the new core component is going to be the LRAFT module with all the automatic leader election. This allows us to lose basically up to half of the nodes and drafts still remain in functional state. The log replication also gives us strong guarantees that whatever gets in there, once it's committed, it's actually not going anywhere. You'd have like ability to have non-voting nodes as well. And all the entities would basically, like your HA stack will determine which kind of targets would be kind of more important and which are less important. So this picture demonstrates how when you have like 3 MDTs per node, still there's going to be only a single service per node, but it could be attached to one target. Typically, whatever target would start first on the node would attain the service, but once if, for example, there's a failover and you want to bring some target down to move it elsewhere, it will just migrate to whatever remaining services there are. This service probably the mouse probably isn't working. The service updates arrow you see is actually done outside of rafts. This is basically to show that the clients could still talk to every MDT, whatever MDT is more convenient for them directly, but it's that MDT/service that's going to forward messages to the leader before they're officially distributed and are captured in the, in the actual service log. So for the fault-tolerant quota, right now the quota master lives on MDT0, so you lose that, bad news. We are like going to have the raft node on all the MDTs now that would, should be able to migrate away no matter where they are, no matter where the leader is, and to improve resiliency also, and kind of reduce the load as well. We plan to implement a way for the clients to talk to any MDT for the quota information, and then internal forwarding will actually find its way to the actual leader. Obviously, improves the reliability for the configuration log files and stuff. So here's how, for example, the second quota would work. So the request will be sent by the admin to any MDT, whatever, then forwarded to the leader. The leader would record the entry, and then the whole setting is synced across the cluster, and only after we've got enough confirmations of commits from those followers that it takes effect and the client would get its response. And now also you could retrieve this information from any of the MDTs when you actually query the quota information, so you don't actually need to go and hammer MDT0 all the time like you are today. For the grant update, it's actually updated a lot more frequently, so we are going to batch up the updates. And like in case of a loss of a leader, it's probably just easier to just regenerate the whole information as necessary, but since we don't expect it to happen all that often, that should also kind of simplify some implementations. The load balancing is going to be implemented later, but like I mentioned, it is something that we are looking forward to because, number of clients is only going to go up. That's the reality of it. We are constantly hitting all sorts of limits. So we also plan to split the quota master. So today it's only a single one. We are considering to allow per UID or per project ID or whatever makes sense for you per quota master. So on the quota slaves, they could talk to different quota masters for those different things, but if whatever ID you chose to split on is the same, it obviously must be the same kind of master node anyway. the file location database, the feed location database. It's a very important service that tells clients where the data they are going after actually located. So like a feed into an actual service instance. It does need strong consistency, but it, the updates aren't exactly super frequently done. So Raft still will work here, or undressings. Maybe we could even do something simpler, but Raft at least, since we are already having it, might work well there. No kind of big complications expected here. The special resource locks that are typically living on MDT0, again, Raft will decide which node is actually holding them at any one time, and if it migrates, all the operations go there. Unfortunately, no easy splitting of that, so it still remain kind of single node that holds those. Now the actual redundancy for the inode metadata. Surprisingly, there are now several competing ideas. The initial one that's kind of several years old that we've been chipping at for some time, the very traditional one, small chunks. So we'll get like inode pointers that would allow you to point to multiple feeds for your mirrors, and then phased approach. So first it's going to be super top level directories that barely change, and then we'll add kind of offline replication, very similar to what we've seen with the erasure coding, and prior to it to the mirrors. Slow and steady, but it does have quite a bit of an impact on how much extra metadata gets written, all that stuff. And the FS check complications are massive potentially if things kind of get bad. So recently LUG came up with this other idea that you could get the HLD at this link. But basically, the idea is a greatly simplified approach where there are going to be fixed mirroring at the file system creation or kind of mirror initiation time. You just select how many mirrors every metadata object gets. You don't store those mirrors separately. Instead, the feed structure would be adjusted, and the top 3 bits of a sequence would work as your mirror IDs. That would support up to 8 replicas per file. So here's an example of like a regular feed and the 2 mirrors for the case of like 3 mirrors information. We would only store the normal feed as a pointer, as is the case now, but we will remember in the other place how many actual replicas are there. And in the FLDB, we will record all 3 of those sequences, and they would be pointing to different MDTs. And when you write the transactions to those other MDTs, automatically inside the feed is replaced to whatever is one that fit in that one. So automatically you have parallel X trees totally replicated. And if you lose one of them, it's totally trivial to recombine it back. So you don't need to like really extend your extended attributes to store all the like random feeds. As long as you are totally content with having a very fixed mirroring kind of scheme. And then, like, if one of the MDTs gets deleted, you just reassign those feeds in the FLDB to another MDT, and just using the other available mirrors, you would just reconstruct, or rather recopy the information. So it should be pretty simple. There are no complications from fs check, because again, the tree always remains the same. It's just, like exact mirrors all around. Yeah, but what's common between those two approaches is that distributed transactions that are required to do all those writes are currently very expensive. And so before we do any serious kind of relying on those distributed transactions, we really need to make that work faster. So we have a ticket for that. There are all sorts of like ideas and stuff. And so this is one of those kind of stepping stones that we have to rely on as well. It's kind of very important. And metadata is the last place where we actually could afford to become slower. Not like Lustre is known for its, super blazing metadata speed, unfortunately. And I think that's it. Questions?
From the audience. Any questions?
Hey Oleg, you pointed out the distributed transaction problem. I mean, if it doesn't get any better, what does it do to the viability of metadata replication? Do we have any leads on speeding that up?
Yes, so if you actually go to this ticket, there's a whole bunch of kind of lower hanging fruits identified. So, I mean, we have no other choice. We actually have to make it work much better. Anyway, like for multiple reasons, we already use the distributed transactions as part of DNE and other such kind of places.
Just to follow up, do those ideas solve any of the problems with failures of distributed transactions? It seems like it's pretty fragile and brittle right now.
No, that's a separate can of worms, unfortunately.
Thomas Berchinger from Lanel. I was just curious, with the plan to potentially use 3 bits from the FID to store the replica ID, are those bits used right now? Like, could there be any FIDs out there that have those set?
So those are the highest bits. So unless you already have so many sequences that you've used all the way up there, but we don't believe anybody got that high or will get there in like any reasonable time.
Okay, thank you.
I had 2 questions. First, on the fault-tolerant MGS, it seemed like you were saying that Raft wouldn't be running on every node. And then for quota replication, you said it would be running on all the quota, like it would be running on every MDT for quota.
So those services are different, right? So it looks like we don't really need Raft for MGSs because, there's no need for strong consistency on MGS in a way, right? So the information rarely changes, and so having one authoritative master is okay, and everybody else could be just, cache and proxies in a way. So we could bolt on Raft there later for this, but it just doesn't seem like it's required, and as such, overcomplicating things isn't a great idea. So if we decide later that it does make sense, adding it on isn't going to be too complicated. It's just doesn't seem to be actually necessary.
That makes sense. I'm thinking towards the mount option of, voting nodes and non-voting nodes. It would be nice if people didn't have to decide that, and it kind of just happened automatically.
I mean, because there are no deployments yet, and the development is kind of in its early days, there's no clear understanding how much of importance that would be. And so this is why it's a little bit nebulous like this. But once we actually have some tests and deployments, we'll quickly see how much of hand-holding does it need and which improvements does it need to actually work okay in production.
That makes sense. I had a second question was, with something like FLR, right, it's envisioned that both mirrors would be readable and you'd get more read bandwidth. For metadata replication, is the same thing envisioned? Would that be possible? All the metadata replicas you could read from them and get more performance?
I mean, that's certainly possible. How much that would be needed is unknown. So, like, there actually might be some lock-in complications. So maybe we don't want to do that without actually primary node, just because, you know, you really don't want to do some lock-in operations on one node and conflicting operations on the other one without actually somehow like having the node stock. And now this crosstalk is probably going to slow everything down anyway. And just for pure read operations, it sounds like it might be a win, but again, if a write operation comes along, how are you going to make sure the other node is not holding some locks? So it's unfortunately not as clear-cut as, you know, as it sounds like on like surface.
Yeah, because I was wondering if I could envision people having a very small namespace. They have a single MDT, and then they just have tons of replicas instead of using DNA, and if such a thing were possible.
But you don't get any benefit in actually writing there, right? So if you have a read-only set, maybe, but if there are any writes whatsoever, then the benefit might not be there. Like, you know, majority of complaints about metadata speed in Lustre comes from, oh, we couldn't write those files fast enough. It's not that, oh, we couldn't start like millions of files per second. That's not a problem we have today.
Makes sense.
Any other questions for our speaker? All right, seeing none, let's give him one round of applause.